All right, so we're doing 8.4 C through D, solving polynomial equations. What C through D is focusing on is our special cubes, factoring our special cubes, our special cubic polynomials. So part C, we are gonna talk about the sum or difference of cubes formula. And so with the sum of difference or difference of cube formulas or rules or factoring techniques, there is a pattern that follows. If you have two perfect cubes that are being added together, you can factor them using this rule. So it's a pattern that you're going to follow. If it's the sum, it's going to be a plus b times a squared minus a times b plus b squared. Okay, so if you look here, we have 8x cubed plus 1. So to find our a equals the cube root of 8x cubed, which is 2x. To find our b equals the cube root of the second term. And the cube root of the second term is just 1. And then you're just plugging them in where a and b would follow. Do we see that? Okay. Same thing for subtraction, except the pattern changes. Now, how I remember which order to put my signs in, I remember it as same. So it's the same as how I started. It's the opposite of how I started. And this is always positive. So same, opposite, always. It's going to be same, opposite, always. Same thing. It's the same how you started. So you notice how they're the same. Opposite, always positive. Same, opposite, always positive. And so if you look here, the only difference between these two factors are the signs. Not everything else is the same. Okay, ready to do some examples? Let's dive on in. So here we have x cubed plus 27. Okay, I know that it's a sum situation because it's a plus sign. So to find my a is going to equal the cube root of my first term. And what's the cube root of x cubed? X. To find my b is going to equal the cube root of my second term, which is 27. The cube root of 27 is? Cube root of 27 is 3. 3 times 3 times 3 equals 27. And now I just have to plug them into their respective locations. So because it's sum, I have a plus b times a squared minus a times b plus b squared. And I'm just going to plug them in where they go. So I have x plus 3 times x squared minus x times 3 plus 3 squared. So I want you to see that I literally plugged a and b exactly where they went. I'm going to clean this up. So I have x plus 3 times x squared minus 3x plus 9. And that would be my factor. How we feel? Simple? Don't we love rules and formulas? Yeah. All right. Now, it does not matter if there is a number along with the variable in the term. You're still going to follow the same thing. So here, I know that it's sum. I know that I am still doing a plus b times a squared minus a times b plus b squared. All right. So to find my a is going to equal the cube root of my first term, which is 8x cubed. And that gives me 2x. Perfect. B is going to equal the cube root of my second term, which is perfect. Cube root of 125 is 5. Now I just got to plug them in where they go. So I have 2x plus 5 times 2x squared minus 2x times 5 plus 5 squared. So that gives me 2x plus 5 times 4x squared minus 10x plus 25. Okay. So did anything change just because there was an extra coefficient? Nope, same thing. Okay, what I do need you to be mindful of is when you are squaring, make sure you are distributing that square to the coefficient and the variable. Okay, so notice how it's 4x squared, not just 2x squared. Okay, make sure you distribute the coefficient, distribute to the coefficient. All right, the next examples we're going to do are having to use GCF prior to using the cube rule. So just like always in any factoring situation, you want to check to see, is there GCF? Is there an obvious GCF here? Yes, 3x. So I'm going to factor out 3x, and that's going to leave me with x cubed minus 1. Okay, your GCF has to be part of your final answer. If not, then your answer is not correct. So now I'm at the point where I'm like, okay, this is difference of cubes. So because it's difference, my rule is now a minus b times a squared plus a times b plus b squared. And for this one, my a equals the cube root of x cubed, which is x, and my b equals the cube root of 1, which is 1. So when I write this factor, remember, I must always include my GCF. So I have 3x times x minus 1 times x squared plus x times 1 plus 1 squared. I'm just going to write it out so you can see that I put everything where it goes. As you get better at this, clearly you can do some mental cleanup, less writing on paper. So we have 3x times x minus 1 times x squared plus x plus 1. And that would be my final factor. Mm-hmm. All right. Cool. All right. So I'm going to pause and let you try this one. All right. Check yourself. How do we do? Okay, and make sure you don't forget the greatest common factor because it's still a factor, right? And make sure you distribute your power to the coefficient. Huh? Because it's 2x, the power has to distribute because you're squaring all of A, not just part of A. You have to square all of A.
I almost had it wrong. I had left 27 right there first.
All right. Okay. Now, what if you have multiple variables? Okay. Does it change anything? The answer is no, it does not. So, but the first thing we should check for is what?
GCF.
And is there GCF? Y is, there's a y in each term. So we're going to factor out the y first, and we're left with 64x cubed plus 125 y cubed. And it's summed, so we know we are doing a plus b times a squared minus a times b plus b squared. So in this case, what's my a and what's my b? The cube root of 64x cubed is actually 4x, and then the cube root of 125y cubed is 5y. So when I write the factor, I'm not going to forget my greatest common factor. So I have y, and I have 4x plus 5y times 4x squared minus 4x times 5y plus 5y squared. It's a lot. You're just plugging the values in where they go, substitution. So my final answer is y, 4x plus 5y. And remember, make sure you distribute your power. So we have 16x squared multiply minus 20xy, distribute your power, plus 25y squared. And that is the full factor. Okay? How do we feel about part C?